is joining right now, but so in this stream we are going to do a Collab notebook. I'm trying to get a GAN working in a notebook. I'm only streaming right now with this kind of ghetto webcam here because I don't have an actual webcam. So some people wanted me to stream from my big PC, which I'm doing right now. So I'm gonna quickly listen to myself here. I'm gonna mute my mic and I'm gonna listen to the stream. So give me 1 second. I should be live, but okay. So now I'm unmuted again. Yeah. So I don't know what I'm still waiting for. Let's get cracking, I guess. We can turn this down, and I'm gonna delete the viewer account. Quickly, I'm gonna plug my stream everywhere. I should definitely stop. What's it called? I should probably log out. Let's see. Let's see. So, all right. So, that's one. We can get rid of this. And let's post it quickly to the machine learning subreddit. Why TF data is better than... Huh. So this and then... No, I forgot the title. Oh no. I didn't change the title. This is episode 10 already. Oh no. I hope it changes. So that's episode 10. Awesome. All right. So I'm gonna quickly plug it on the machine learning subreddit. So let's post this in here and get the title as well. Yeah. All right. Let's go. Okay. So let's get cracking. Let's start with superwork. So I got a new mic, so that's really cool. This is for my thesis, actually. Let's see. Stream 9. Stream 10. What day is it? 25th. Oh, I want to delete this. Yes. I want to copy this. Alright, so stream 10. And it's the 25th of 2018, right? So in this notebook, what are we going to try and accomplish? We want to train a GAN, in this session, in this stream, I want to train a GAN in a Collab notebook. Things that pop to mind are looking for people who already did so, and finishing with a polished project that we can show to others. Why is this valuable and important? Well, I mean, GANs are pretty cool. And we've been trying to get one to work for quite some time now. So the fact that we figured out that we have those Collab notebooks is awesome. If we can generate images, we are done, I guess. The internet, Reddit, social media, phone, etc. Ambiguous or concrete? Kinda concrete, I guess. Anything else noteworthy? Not really. So this is my first stream. This is my first stream as a Twitch affiliate, which is pretty awesome. I mean, I'm not pulling any viewers. I'm pulling 0 viewers right now. That's actually really funny. But yeah, this is my first stream as a Twitch affiliate, and hopefully you guys will enjoy it. I'm sure as hell enjoying it. Kind of surprising I have 0 viewers. Maybe I picked the wrong hour here. We'll see. Maybe some people will trickle in. All right, let's see. So I'm gonna set a timer, and then I'm gonna start cracking. So let's set a timer for 45 minutes. What is the one thing I want to accomplish? So in this session, I want to accomplish loading in the MNIST dataset in a Collab notebook, which should be relatively easy because we did that already. Then for the second goal, I want to look for a GAN tutorial online, I guess. How will I get started? Open Google Docs. No hazards. So let's go. Let's do that. So let's open our my drive, then Collab Notebooks, and all right, so we did this last session. So we trained actually a whole algorithm, right? So we can get rid of this, I guess. Let's get rid of this. Then we had to install Keras, and then we ran the contents of the file. But yeah, so let's try that again. Let's try running it and see if it works. So runtime run all is Control F9. So let's Control F9 this. Excuse me. So now it's running. Hey viewer, how are you? Good evening. Enter your authorization code. All right, so let's enter my authorization code. Sign in. Sure. Sure. We did this already, but I guess you have to do it every application. So we entered that. Sure. Shit. I think that was not what I should have done. Pip install Keras. All right. Test samples 177, line 42. What? Okay. So this actually worked, but let's try and run below. Drive already mounted? Sure. Okay. I commented this out, okay. And now we should be able to run this. Why are so many typos in here? Okay, so now it's training. Our goal of today is to load in the MNIST dataset. So we did that. So that's proper. That's a plus. But we kind of want to. So we remove dropout from there as well. You can just import the MNIST dataset. So. "16 seconds. Channels first. Okay, so let's look at Keras dataset. So it has multiple data sets, actually. It has Reuters. Oh, that's cool. All right. So it has like MNIST data set, which is Keras data, import MNIST, and then X-train, Y-train, access Y-test. So let's quickly try that. So we already have this. I'm going to copy it, but I'm going to type it over anyway. So we have X-train, Y-train equals X-test and Y-test. All right, MNIST, load data. So MNIST is like a class, I guess. So you can import the class, right? So can I go into the documentation to see what that looks like? Let's see, Keras, and then datasets. Keras datasets, and then we have MNIST. So we load path. So it downloads it. np load fx train, fy train. All right, cool. So this is kind of the file I was looking for. All right. It's two tuples, uint. All right, so let's open a gvim. We want to load. So loading the. So that's actually relatively easy. Actually, like really easy. So let's make a nice. Let's make a text cell. Loading the MNIST dataset is trivial. It's really easy using Keras. We import the MNIST. We import the MNIST file and run the load data. Run the load data function. We import so that's really nice. That's easy, right? And that gives us what's it called? Let's see what xtrain looks like. I'm gonna put it to the other side. I hope no one minds. Or maybe I can do it like this. Yeah, this should work. Sure. So we load in the data set. That's one. We can get rid of this, I guess. Now let's keep this as a backup. All right, let's see if we can find a tutorial for a GAN in a Collab notebook, like GAN, Collab, MNIST dataset. Simple GAN. Theano. ICCV. Channel pruning. Seems like an interesting paper. Hey, Leyendecker, what's up, man? How you doing? Are you still here? Cause I don't know, maybe my viewer count is bugged. I see that I have 0 viewers, so maybe I've become suddenly really unpopular, or something's wrong with my viewer count, which might also be the case. It's good to have you, man. Yeah, just chilling a bit. I have this is the green screen you usually can't see, but today you can see it because people ask me to stream from my big computer, so I don't have so much trouble with the lag. So now I am streaming from the big computer, but yeah, I haven't figured out the software yet. So my idea for this stream was to get a Collab notebook working, trading a GAN. So we did a lot of stuff with GANs, right? We studied the whole properties of all the GANs, but we never really got to making an actual working GAN. And then we figured out that we have this awesome Collab notebook where we can just use free computing power from Google. So that's I thought it would be a nice goal to have, right? To program in a GAN. And here we have a simple convnet which trains on the servers of Google. I didn't write this. We just copy pasted this from someone else. So and here I'm gonna try and strip apart this and then turn it into a GAN. I don't know how, but I guess we're gonna figure that out. So Control MD deletes a line. Control MD, sure. Okay, so that's loading in the data set. And then let's see if we can have a GAN. GAN in a Collab notebook. Trading GANs using Google Collaboratory. I just want like the simplest GAN we have. And I'm actually kind of curious what a K80 GPU is. A Tesla K80. Those things are $7,000 euros each. Wow. All right. That's pretty crazy. All right, so getting started with Collab and trading GANs. All right, this seems like a really nice tutorial, right? So I'm gonna write that down. Just gonna quickly. I can put it in a Collab notebook. You can just make a new thing called sources or references, right? Sources. I'm really interested in GANs and don't know much about the training. All right, I can explain it. I mean, do you know what they are? Do you know what the GANs are? Because I can explain it again, because we did that on stream, right? We did that on stream 2, 3, and 4, I think, but I don't recall. But I'll go over GANs again. I think it's 2015. I mean, yeah, like, yeah, in the sense that you don't know what we're talking about, or yeah, that we did that. You missed a GAN stream. Okay, so that's fine. I can talk it over again. Pun intended. GANs are not that difficult. GANs are really cool. So the main idea behind GANs is this picture. There's no picture here. So let's go back to a GAN. Yeah, that I know what they are. Yeah, so anyway, I'm just gonna recap it anyway because I think it's a cool idea. So again, I'm looking for that one picture we had, right? Not this one, but another one. So GAN model. Let's see, what's a GAN? Oh, GAN model. Not this one, right? So can I copy this? Oh, actually. Yeah, it's on my other computer. So the main idea, right? Oh, that's ugly. The main idea is that you have two models. So I don't have my tablet on right now, but the main idea is that you have two models. The first model is the generator. And what the generator does, the generator, can I type here? So the generator turns noise into fake data. That's basically so you put in noise and it creates fake data. That's step one. That is like step one. This is step one. And then what step two is doing is that we have the discriminator and we also have real data. So we have a set of real data over here. So this is real data. The training image is above. And this is fake data that we like create ourselves. And then the main idea is that after creating fake data, we have a discriminator which tries to separate real from fake. So the separator then tries to separate the fake data from the real data. And by doing that back and forth, by going back and forth between training the discriminator and the generator, they both become better and better and better over time. And so that's the main idea, that we constantly go between, we iterate. First we train the generator, then we train the discriminator, and then we train the generator again, etc., etc. So we go back and forth between training this one and this one. And hopefully, in the end, what we're left with is a generator that can create fake images that are very convincing, And at the same time, we train a discriminator that is really good at separating fake images from real images. So that's the main idea behind the GAN. And we're gonna try and implement that in Google Colab. So hopefully we can do that. And we just found a tutorial, right? TensorFlow. No. Yeah, so here we have the same idea. We have some random noise, and you turn that noise into into a fake. You create fake data, like a fake painting, and you also have like real paintings, and then the discriminator tries to separate those two. So let's write that down actually, because I want to make a notebook that kind of explains everything. I think that might be really cool. So so let's make a GAN, like a generative. So introduced by Ian Goodfellow. Let's look up that paper. Yeah, MLA. Introduced by one. Does it link? Let's see. Huh. Anyway, introduced by Ian Goodfellow in 2014, GANs have taken the world by storm. So okay, I'll type a bit about that, but the main idea behind GANs is pitting two machine learning algorithms against each other. A nice analogy is that of a team of counterfeiters. A nice analogy is that of a counterfeiter creating fake currency, and the police trying to separate fake from real currency. So every GAN model has a generative model. So every GAN has a generative model. So let's call that G. So that's this part, the generator, and a so every GAN has a generator or a generative model and a discriminator or a discriminative model. D. The generator is a function that takes in noise, or it's not a function. Yeah, it's an algorithm that takes in noise and outputs fake data. Fake data. Whether, so that can be images, text, whatever. Can be anything. Then the discriminator, the generator is an algorithm that takes in noise and outputs fake data. The discriminator tries to separate the generated fake data from the real training data. Then by iteratively training the generator and the discriminator, both models become better, and hopefully what we end up with is a generator that can create convincing fake images, and a discriminator that is very good at picking the two apart. So that's the main idea, right? So let's read that. So introduced by Ian Goodfellow in 2014, GANs have taken the world by storm. The main idea behind GANs is pitting two people. Do you spell that way? Pitting two pig dealer. Pudding. Or is it like pithing? Pitting to pit against, right? Pit it. To pit something against. I think it should be correct. So the main idea is pitting two machine learning algorithms against each other. A nice analogy is that of a counterfeiter creating fake currency and the police trying to separate fake from real fake currency. Yep. Pitting, right? Yeah. Fake currency from real currency. So let's put this let's put this in the back actually. So the main idea is pitting two machine learning algos against each other. Every GAN has a generative model and discriminative model D. The generator G is an algorithm that takes in noise and outputs fake data. The discriminator tries to separate the generated fake data from the real training data. So we have to take these things like really literally, like actual, like the generator G like it is an algorithm. It's nothing more. It's just a function. And we are going to train this algorithm. So we made an extensive write-up actually on my other computer about the GAN, and I will put that in the. I think I'll put that in the notebook as well, but only at the end when we are done with. Let's delete this. All right, so that's a GAN, and I'm gonna try and see if I can insert an image because I. Text, and let's see if I can get an image in there. Insert link. Okay, so let's go to Imager, I guess, and upload that GAN image. All right. Sure. Oops. Is this gonna work? No, I need the direct link. Oh, that's pretty neat. That's cool. Yeah, so the following figure gives an overview, gives a schematic. Let's see if this looks nice. And then so we see that so again the generator literally takes in random noise and outputs fake data, and the discriminator tries to separate the fake data from the real data. So that's the main idea. Nothing more, nothing less. It's a pretty cool idea. I think it's a really cool idea. And it has some pretty big, it had like a huge impact, right? So people are using GANs all over the place now, but we have to keep in mind that we have to always keep in mind the main idea, like what is the core thing that makes a GAN a GAN and a GAN. And the core thing that makes a GAN a GAN is the fact that it has a generative model, which is why it's called a generative adversarial model. And it has a discriminator model, which is why it's called the adversarial model. So adversarial in this context means that we put two algorithms against each other and make them duke it out. Then the reason it's called a GAN and not just like a generative adversarial model is that in the original paper he uses two multi-layered perceptrons. So let's see. I think it says somewhere here. So in this case where G and D are defined by multi-layered perceptrons, the entire system can be trained with backpropagation. So that's the reason why it's called generative adversarial nets. And the adversarial nets is then in particular, so where we have two neural networks. So that's pretty cool. I think that's really cool. So any questions about GANs are of course greatly appreciated. I'm gonna make it GAN here. I'm gonna type GAN here. So I think we are using this tutorial. So okay, we're doing this. We're doing this. Sure. Generative adversarial networks are the next big thing in deep learning. Okay, so we're doing deep learning actually. We're not just doing machine learning. So consider me now curious what the difference is between deep learning and machine learning. What's the difference? Because I'm stumped on that. I think it's kind of like the easiest way, concentric circles. So, okay, we have AI, machine learning, and then deep learning. This doesn't really, deep learning is machine learning. Yeah, I know, right? But I always thought that deep learning was about like having like many deep layers in neural networks. That's what I thought. Like, if you have a neural network with like 20 layers, it would be deep. Yeah, that's what I thought. But I don't know. People use buzzwords a lot. So, all right. So, okay. Oops. I already have voiced my frustrations with Medium. You guys know that I hate Medium, but okay. People write on Medium, people read on Medium, so I guess that's that. So, generative adversarial networks are the next big thing in deep learning. As the name suggests, GAN is a combination of various deep learning models, so many times deep learning, trying to compete with each other to fulfill the most basic need in any deep learning project, generating more data to train on. I always advise you to read these articles with a bit of skepticism, because this is not exactly what a GAN is used for. This is I mean, it might be his need, but a GAN is not. This is not the main goal of a GAN. The main goal of a GAN is to. So what a GAN tries to do, like this training set has a certain distribution. Hey, just me, bro. What's up? It's nice to have you, man. Yeah, you tuned in at the right moment. Because I just started. I should probably have given a heads up. Yeah, I'm not saying it's a bad use of a GAN, right? But at least how I interpreted the paper. So this is this can be, of course, is open for discussion. But what I thought was that this training set has a particular distribution, which in the paper we call P something. That's written here. So this training set has a certain distribution of features, and the goal of the GAN is to train the generator in such a way that we can create fake images that we kind of approximate the distribution of the training set, right? And then, of course, if we have done that, then it can be used to kind of then we can use it to generate more data. But I don't think that is necessarily like the core of what a GAN tries to do. I think, at least. So Leyendecker says it's a very good use of a GAN. I have read papers that use GANs to create data sets. Yeah, I'm not saying you cannot do that, but I don't think that's the main. Like, so then the main idea would be you train a GAN, and then you use that GAN to kind of generate more data. That's possible. That's indeed possible. But then you're using your generated data to like train another model on. I'm not sure how robust that is, but it might work. I'm not convinced, but maybe you can try and convince me. All right, so here we'll try and train a GAN, and it consists of two models, which we discussed. It has a generator, which will try to generate forged data from existing data, and will try to fool the detective to be real data. and the discriminator, which will be the detective trying to catch forged data, right? So that was the main idea. So I'm gonna draw it again. So let's draw it again. So we have so let's say we have real data here. So let's call this real data. Then we have a discriminative model. Let's make that black or red. Let's make it red. So this model is a discriminative model. Discriminative. Like, and then we have the generator. And the blue line is the generator. So we kind of have to realize what so the generator creates fake images, right? So that creates fake images. But we have to realize that the only thing the discriminative model sees is just an image, right? It doesn't see anything else. It doesn't see whether it's real or fake. If we are looking through the eyes of the discriminative model, all he can see is images. He sees images like this image, this image, this image, and he doesn't know whether it's real or fake. So what the discriminative model is going to try and do, it's going to try and say, okay, so I think this one is real, I think this one is real, I think this one is real, and I think this one is real as well. And then by the generator is then going to check like, okay, so which of the images I made fooled the D model and which ones didn't, and then it's going to update itself, etc., etc., etc. Let's see. So GANs don't only produce from random noise, they can do transfer as well. What do you mean with transfer? So I think that you mean style transfer, right? Or you mean transfer learning? All right, so let's while you answer the question, let's get cracking on the code. Okay, competing against each other, these two models will give us the best possible new and unseen data. Okay, so I don't agree with this. If you're more into deep learning and need more details, you can follow this tutorial, or you can watch my streams, of course. GAN is about creating. This kind of looks like style transfer to me, and not necessarily like a GAN, but the GANs can do style transfer. So this is cool, right? So this is kind of generating fake images with GANs is kind of what gets media attention. I saw this paper, I saw this exact architecture somewhere. This was published in ICCV, I think. Yeah, so yeah, this is a nice image as well. Yeah, and we did this on stream, right? So you can go back to my old streams and we actually discuss all of this. Well, not all of it, but most of it. We also go over this. We also go over this thing over here. Okay, whatever. Let's train again ourselves. So this is what we want to do. This is what we want to kind of program in on our own. Let me see, a Leyendecker. I'm gonna open your gonna open it over here. Oh, I can't see the chat. I'm gonna open it on another. You sent me a PDF document. Generated hands for real-time 3D tracking. Wow, what? That is crazy. Real-time 3D tracking from a monocular RGB only. Wow, that is crazy cool. Are they serious? Stanford, Saarland, MPI Informatics. Kinematic 3D hand model. It generalizes to unseen data, robust to occlusions. That's pretty cool. That's really cool. We should we should keep this in mind, and because that is, I think, so another. I have a lot of problems with the current state of the art machine learning. So my first problem is that I don't think that our brain works the way all the current machine learning algorithms do, right? Our brain thinks in like 3D and not in 2D. So you don't feed a baby 10,000 pictures of a cat and say, look, baby, this is a cat. No, you let him play with the cat, and then he finds out that cat claws are sharp and that cats are furry and that sometimes they are meanies, right? So I think our brain works more in 4D or in 3D plus time, which you can kind of interpret as 4D, right? And not like the way we are doing machine learning right now. So I think that 2D to 3D modeling is very important. Excuse me, sorry. Okay, so let's get back to the tutorial. So we're gonna use Torch for this tutorial. Okay, I'm just gonna, so a good idea doing anything is to scroll through the tutorial, like kind of prime your mind, like what are all the steps that we have to do. So we are using the MNIST dataset, so for sure we have to load that in, which is relatively easy in Keras. So we're gonna do Torch Vision, and we're gonna do TensorBoard X, and we are going to install PyTorch. Okay. Make sure you're getting GPU. Okay, so we wanna enable the GPU later on, right? So preferences, I guess. Help, no edits, and then file. View. Change runtime. Yeah, GPU. The dataset we would use is to download it. So we downloaded num batches. Okay, so for the discriminator, he uses a three-layer deep neural network with sequential, linear, and leaky ReLU functions. Does anyone know what a sequential layer is? I'm gonna Google it. So if you're quick, sequential layer is a linear stack. So it's just that you stack it linearly. So okay, that's fine. Okay, so we create then two classes. One of them is the discriminator. The other is a generator. I don't know why he posts its like screenshots. Initialize, feed forward, hidden 0, hidden 1, hidden. Okay, so now my question is, what is the NN? Where's NN? NN dot super. Okay, then we create the noise sampler. So I'm just gonna quickly scroll through the code to get like an idea of what he's doing. So this is the discriminator net. So that is this thing, which we so first we create the so the discriminator, of course, is this thing, which is the red thing over here. The generator creates that, and the generator is also just the neural network, right? So that's the beauty of this. Is this standard code for Keras or PyTorch? It looks nice. Okay, so and then we create the noise sampler, initialize, and we use the BCE loss. What's BCE loss? We will also define functions which will help us targeting. Okay, it's a 1D vector of Gaussian. Okay, so here we use standard normals. We could have also used uniform from 0 to 1. So we understand the noise samplers. We understand the optimizer. Generator dot parameters. And here we have a parameters. Okay, so we have generator is generator net, and we initialize that with a torch NN module. Sure. I don't understand what the super thing does, but we'll figure that out, I guess. I'm gonna write that down. So what is the super thing? No, let's put that in the notebook. So let's put it in here. Maybe something like other notes or something. Notes. So we have to find out what does super mean? So super Python. Working with the Python super function. All right. So what's that? It's something from Python 3, I guess. No, Python 2.2 actually. Returns a proxy object to the delegate method calls to a class. That description may not make any sense unless you have experience working with Python, which is very true. The super is the heritage thing. Let me see. So essentially the super function can be used to gain access to inherited methods. Okay. I'm being called. No, I'm not being called. That's my timer. So that's already 45 minutes. Congrats on your first Twitch stream. You did it. Wait, this is not my first Twitch stream. Okay, so we have a quick break now. Thank you so much for my 3 viewers who are tuning in today. If you've been here before, I think one is Liondecker, one is Just Me Bro, and the other one I haven't seen in the chat yet. So thank you all for having me. I really hope we can get a GAN working today. So wait, so let me let's answer this question. So what does super mean? Well, maybe post like a right arrow. It allows you to inherit from other objects. Wait, how did they? It can be used to gain access to inherited methods from a parent or sibling class. Yeah, allows you to inherit from parent, to inherit methods, to inherit things from parent or sibling class. Awesome. So I think the goal here is, or the goal, I think the why we are doing that is such that we can call the functions from torch NN module, right? Because it's in all honesty, I haven't worked that much with inheritance in Python, but my guess is that we are making a torch NN module thingy. So let's look at that code. So torch NN module. Torch NN. I hope it's open source. So it has parameter, and then it has base class for all your models should also be a subclass. This class modules can contain other modules. Tree structure. Define forward. Add module, apply, initialize weights, children, CPU, CUDA, double dump patches, eval, extra rep, half, forward, so forward. Defines computation and average should be overridden. Okay, half, load state dict, Named children, dropout layer. Okay, so here we have. Okay, so let's see. So what did we do? Load in the dataset. So we did that. So we loaded in the dataset. And we actually, we are working our way through the GAN tutorial. Yeah. Any distractions? No. Things to improve next cycle? Tell me. Okay. As you guys know, we have a break every 45 minutes because that is healthy. And that break time is now. So let me say break. Yeah, break time. Tea break. So don't leave. Or, I mean, of course you can leave, but I hope you will stay with us so we can program in a GAN together. Because that is our goal for tonight, to get a GAN working. And I think that is really exciting. So where is the outline? Here, outline. Now let's make it a bit bigger. And make it black as well. So like, so the goal here is to finish a GAN. So that's gonna be our goal for tonight. And I'm pretty sure we can achieve that. I'll be back in 5 minutes. Because I'll be making some tea. My water takes 3 minutes to boil, and then I think 2 minutes to put in a tea sachet is a good estimate. Okay, I'll be back in 5, yeah? And don't mind the pants. I'm wearing pink pants with hearts on them, so. Oops. Hey guys. Thank you guys for tuning in. Those who were willing to stay with me. All right, so let's get back at it. All right, so what would be a reasonable goal for us in the next session of 45 minutes? So let's make it a goal. Wait, so time finished is let's say 18:55. Let's make it a goal to read through the whole tutorial. That seems like a short goal, but I think it's a really nice goal. And then if we might just start working on the tutorial. How will I get started? Scroll through. What hazards? Internet, phone, Reddit, whatever. So the main thing is that we want to get a good overview of all the things that we have to do. So first I'm going to scroll through the tutorial a bit. So first we have to install stuff. We have to install PyTorch. So things to do, right? So let's make it things to do. Install PyTorch. That's the first thing. Then we have to load in the data, which should not be that difficult. Then we need to make the discriminator and make the generator. Sorry, excuse me. We have a logger, which is okay, sure. We generate noise. And we take the BCE loss, which I don't know what it is, but I think it stands something cross entropy loss, right? Something cross entropy. Let's see. Binary cross entropy. Sure. That sounds fair. Okay, so then wow, that is really cool. That is insanely cool, right? So scrolling through the tutorial, it's like freaking, I don't know, like 2 pages. How many claps does this thing have? I don't want to say 100 claps. So I don't want to say that claps are necessarily something that is like, it's just like likes on Facebook, but I think this is a cool tutorial. So okay, then we have to make the generator. Then we do the loss function, the optimizer, the noise generator, and the logger. I'm not even sure if this is like proper. If this is like good code quality, but let's see. 1 hour? Shit. They are original images generated by the generator model. So these new images were never seen by our GAN model before the training. That's true. So like, I don't know. I'm still not convinced. So what he's saying is that you can, instead of making data yourself, you can let the GAN generate it, right? But I don't think that's really a good idea. Maybe it is. I don't know. Maybe I'm wrong here. All right, so let's just, I guess I don't want to say start copying his code, but let's start copying his code because I have no experience with PyTorch at all. So let's see what we can do. So I'm gonna make a copy of this actually. Should I make a copy? Nah, we don't need a copy. So loading in the data, we can get rid of this thing actually. I'll make a copy. Let's make a copy. Save a copy and drive. Okay. Okay, so we mount that, and then we want to install PyTorch. So I didn't want to do that. Okay, so let's delete this. Let's delete this. Delete this one. The GAN thing is good, but we want to delete this as well. And then we want to delete this. Delete this. Delete this. And that's about it. So, yeah, so let's install the prerequisites, I guess. So pip install PyTorch, I guess, and then pip install. So sure. Failed building PyTorch. You should install PyTorch from. Okay, so this is. I can probably go here. Okay, so we want to install this. Okay, let's see if this works, or whether it's an old version. This is kind of buggy, isn't it? And then after that, we want to install Torch Vision. And then we want to install Torch Tensor Board. Sure. Okay. What is a tensor board? Data. Visualizing learning. Oh. Damn, that's cool. I don't think you guys can hear that because I'm playing music. Whoa. TSNE. Oh, TSNE is also something we should maybe. I think some Dutch guy made TSNE. TSNE, let's. Laurens van der Maarten. T-distributed stochastic neighbor embedding is a prize-winning technique. So I'm also curious to find out what TSNE is. All right, so that worked. We can install Torch Vision as well. Okay, and we can install Tensor Board. Why? I don't know, but let's do it. This is a long piece of code, actually. I don't want to copy all that code because I want to write it myself. But what? This is a very long piece. What's happening over here? Oh, wow. Hey, Greeny996, what's up, man? How you doing? Nice to have you here. So today we're gonna make a GAN, or at least we're gonna, I don't want to say copy someone's GAN, but I'm afraid that to use TensorFlow, we'll have to start somewhere. But it's so much code and I don't want to copy everything. Because I want to write it myself, but it's gonna be rough. This is why is this so much code? So we have logger here, and then it's actually not that much. Most of it is just training, I guess. Well, that is pretty cool. Look at this. That is pretty cool. But what is this printing out? So this is printing out every vectors to images, logger display status. Okay, so we have a discriminator trainer and we have a testing training. So this is a lot of code we have to work through actually. But all right, so we have to start somewhere. So where to start? There's so much stuff that has to be done here. Okay, can we just skip the whole logging thing maybe? Private functionality. So I don't know what these things are actually. Static, like add static methods. I know it's called a function decorator, but I don't know what a function decorator does. So our goal this session is to read through the whole tutorial, which we actually did. We actually read through the whole tutorial. So we achieved our goal. And now we want to start working on the tutorial. All right, so step 1, install, create a logger. This is not that important, and it's okay if you do not get what's being done in the logger class. I actually want to know, but I mean, okay, let's all right, let's for now just assume that all this stuff is correct, because this is not really, this is kind of not the main thing, right? So the logger class, so gives a schematic overview. Then we get the logger class, which does all the logging. I absolutely dislike doing this, but let's make some simplifying assumptions. Then we have some more imports. Let's put the imports up here. Can we drag and drop this? Nope. So let's type imports. So this is not how you would regularly make a Python program, right? You would put all the imports on top together. So I don't want to I want to do a learning project with ML, but I don't know what. Any ideas? Oh man, there are so many ideas. I think style transfer, just like implementing a style transfer with, I don't know, pasta noodles. I think I saw a picture of that. Pasta style transfer. No, I had to laugh really hard. Look at this, for example. I thought it was hilarious. It was pasta. And you can do anything, basically. I think style transfer is really cool. The big GAN paper, maybe fast style transfer. Maybe you can consider the kind of loss functions in style transfer, because we talked about that as well a bit on the stream, right? We discussed a fast style transfer, not in detail, but in like small detail. But I want to do some coding again, so that's why we're doing the Collab Notebook, and I'm honestly just copying his code, which I have to admit is a generally bad practice to do that. But we're gonna abstract away from the logger class. We're just gonna hide it and just hope everything works out. because I mean, of course, we could study this line by line, but that's not the point. What I want to show you guys right now. So now we're gonna read in the data, and that is important. So let's read in the data. Keep the logging class hidden, please. 2 cells hidden. Okay, so it stays. Okay, so let's make this data. Load in the data. And then we have a code text behind it. So then we load in the data. We type data is mnis data, where we define a function, mnis data compose. It's just indentation pass. Okay, indentation seems 2 spaces or 4 spaces. This looks like 4 spaces. I'm gonna keep it at 4 spaces, actually. So pass, does this work? Yeah. Do you have Medium membership towards a data science blog? No, I don't. I just Google and then something comes up usually. So let's see. Compose equals transforms compose. I have no idea what we're doing here. I'm trying to do in some reinforcement learning. Oh, that's awesome, man. What is this? So this is just load in. And we're working in PyTorch. I think these are just standard functions or something. PyTorch, torch, mnis dataset. So root data, train is false. Train is true. So what if we just type this? What if we just... Can't we just do this? Datasets is not defined. Why is datasets not defined? Probably because we haven't run this. Imports datasets. All right, then we run this. And now what do we get here? Out there is not defined. Okay. Okay, let's just see what this guy gets. I don't want to... Okay, we're just going to copy it, and we're going to get back to it later. Okay, downloading. Train test 10-2K. So what does the transforms compose do? Transforms to tensor. What is that? What is a tensor? To tensor. A tensor is a multidimensional matrix containing elements of a single data type. Okay. A torch tensor. Sure, I can remember that. So it's just a multidimensional matrix, and why do we need that? Because transform is compose. So let's have a look at data now. Like, what does data look like? It's a 60,000. We normalize it such that it's a mean to a half. Why? This is not necessary. I would personally normalize it and just divide it by 255, but this is possible as well. Okay. Create loader with data. Okay, and then you can iterate over the Num batches is the length of data. Okay, so that is... So we have 600 batches of different observations. So we split the observations in 600 different batches, right? Each of size 100. If we're looking at MNIST, if we're looking at the other one, I think it separates it into batches of 128. Okay. Then we have the discriminator class. Let's see. So that's the data. Then then we have the discriminator class, which is a 3-layer hidden. So then we use a super to inherit. We inherit from torch and end module. We initialize it. Is this necessary? NN features, N out, N features. Self hidden 1. So if we write this a different way, we just get the it just looks like this, right? So if we just stack it like this, basically, which is also interesting. So n linear and n linear. So let's so like notes, things to do, like so things we've learned. So what have we learned? We have learned what super means, or what it can be used for. Then we have learned that NN sequential refers to the linear stacking of layers. And I think if we have like so the NN sequential, right? We type NN sequential, and I think that sequential, by specifying the building blocks, in a cascaded way. Okay, so this is a really nice and intuitive way of building such models. But so let's quickly recap about what the inputs and the outputs are, right? So the inputs here of the discriminative model are 7, 8, 4 by and then stuff happens in between, which is 28 squared, and the output is 1, right? So number of features, which is just the input, is 28 by 28 image. Output is 1, 0, real, fake. I think it's a probability of being real, by the way. So 1 is a real and 0 is a fake. So we have a sequential stack of layers, and then we have NN linear. Okay, so what is NN linear? So let's maybe things or some jargon. Things we've learned. Things. So I want to know what NN linear means. NN linear. So NN linear applies a linear transformation to the data. Let's see. Applies a linear transformation to the data. Okay. So linear and features times in features, out features. In features, out features. And then we have bias is true by default. Um, 1024. Does anyone know where the 1024 comes from? In features, out features. So we use torch.nn module, right? So we look at the code, torch.nn modules, but we just want module. We just want torch.nn module. We want this thing. Is there any linear? And linear. Wait, sorry. I feel really stupid now. Like, so can I run this? So let's first see if I can run this actually. Okay, turns out I can run it. So the arguments here are in features and out features, right? In features equals to out features. This should work, but I don't understand the out features. Does that mean there are 1024 hidden layers? So n in linear has like in features equals, and then out features equals, and then we have bias is false. It was true by default. Let's see. I think it's bias. I think the bias is false by default. I'm not sure. It's either false or true by default. But can I now look at like parameters? Can I type and then dot parameters? So let's see if we can type like discriminator. Bias is true by default. Okay, that's cool. Okay, but can I type now parameters? Any way to get to those parameters? Few parameters. Torch module. Parameter, torch, and then parameter. No, the module, right? Sorry, I'm really confused. Like, so do I understand it correctly? If we have 1024. So questions. Let's make it questions. So do I understand it correctly that if we type that we have that we have a single hidden layer with 10, 40, 20 hidden so in features is end features and out features is like that. So we have that much hidden layer. So this means that we have 784 times, it's like almost 700, almost 800,000 parameters. Is PyTorch dead? Why are you using PyTorch? It's dead AF. Use Google products, much better. Yeah, so I just wanted to get a tutorial working. So our goal for tonight is getting a tutorial, is getting a GAN up and running. That's my only goal. Facebook is going to kill PyTorch like all their other products. And they're probably selling your data from PyTorch too. Or lobbying liberal propaganda. Well, yeah, that's kind of sucks. But I'm going to stick with PyTorch for the moment, just to see how it works. But we are going to use TensorFlow, probably. Or, yeah, because we already kind of... You should hate anything from that crap company. Yeah, I barely browse Facebook anymore. Like, if I go to my Facebook, I think I blocked it. Oh, I didn't block it. I blocked it. I don't like Facebook anymore. It's kind of, I don't know. I don't want to say boring, but yeah, it's kind of boring. Monk ass. Shouldn't you be working? Yes, it should. Did I set a timer? I did set a timer. Okay, so we're gonna assume that we have like that much hidden. So input. So this is the first, well, the 0th hidden layer. So this goes from input. So input is 684 features from 28 by 28 image. Then we have 1024 output features, which results in, let's see what it times 28.4. That's a lot. That's a large number. That much parameters plus 204 parameters, because we have the biases, right? Hey, can I have Superwork v2? Yeah, sure. Let me make a copy for you. I'll make a copy. Wait, let me see. Superwork. Let me make a copy that I can share with you guys. Superwork. Share. And then I'll quickly remove all my content, because no one wants to see my... who wants my work, of course. Is there any way to quickly delete? Let's get that over there for a sec. So let's delete this. Or maybe I can make a new file with single... So here you can see all the things that we've done already. So we've done a lot already. Is there any way to like quickly delete spreadsheets? Google. Too many sheets. Or maybe I can like... Can I make a new one? You can share it and I can delete it. I know, but there might be some embarrassing information in there, and it's not too much, so I'm just gonna quickly delete everything. Because I used some of them, like the last couple of them are personal when I was working on my thesis, which was sometimes a bit of a slog. Yeah, sometimes that was a bit rough, so. Okay, so this is the template. I'm gonna change this for you because you need this to be that one. And we can save it, and now I can share it. Man, am I blind? Share. So I'll do this, and then you can view it, right? You can make a copy. I think you can make an offline copy then. Delen. Yeah, Delen. That's Dutch for sharing. All right, there you go, my buddy. If I now go to a private tab and I go there, let's see if that works. All right, Superwork v2, and then I can probably download it somewhere. File, download as. Tell me if make a copy works. Hey, I have two people. Anonymous Turtle, Anonymous Otter. That's so nice. One of them is probably me. So yeah, I don't know. I really like it. It helps me. It helps me a lot to stay focused. Wait a second. That's me as well. It keeps me focused. And as you can see, we already have done quite some work with the Superwork v2. So I'm really glad I could share it to someone, because I tried the ultra work, but I just thought like there were so many things wrong with it. I really tried, but the main, look, I tried it a lot. Like I tried it for many times, and it's really cool. But the main things that I thought was annoying, that is you have to, there's no room for any error. Like if you mess up the cycle timing, your whole timing is off and you can't change it. And that's the main thing that I changed. All right. So where were we? Read through the whole tutorial. We did that actually. And now we are just, I don't want to say blindly copying his code, but that's kind of what it is boiling down to. So if I'm correct, we have a lot of hidden features here. We have like almost 800k parameters, because every feature goes to the output, right? But then we have the leaky relu layer with a 0.2 so let me see, like nn leaky relu. Why is PyTorch dead? Is it dead? Or is it because you dislike Facebook? We could theoretically set the bias as false and just see what happens. I mean, right now nothing happens, right? But I think we could set the bias to false, because that will speed up training, Of course, it will make it worse, but it will remove a lot of the parameters. So could set bias to false. So that's a lot of parameters. Then we have another hidden layer which takes in. Okay, so this is the second set of, and it takes in 2000. Okay, leaky relu. Then we have dropout. So I'm gonna see what the dropout does. I mean, I know what the dropout does, but I'm just curious to see what the P is. Let me see. It's a dropout probability during training. Some elements of the input tensor with probability P. Okay, effective technique for regularization. Okay, so dropout is also another important thing. Alpha dropout, that sounds something for... Alright, cool. And then finally we have torch and then linear and out, and we have... Okay, I really like the syntax over here. Like, you cannot argue. You can argue, but you have to admit this is kind of pleasant to read, right? I mean, this looks hella pleasant to read. So the forward is that you start with x is self-hidden x, then you apply x. So you input some number, you call over this function, then you just recursively calculate x. Okay, sure. Then we instantiate a discriminator model. And then if GPU is available, we do CUDA. CUDA is GPU, right? CUDA GPU. I think, yeah. CUDA is GPU. What is CUDA? What does it stand for? Or is it just a name? Complete Unified Device Architecture. Solid. So maybe we can make a nice image of this. If I had Photoshop. So let's see if we can make a nice image of this, right? Okay, so we have 1, 2, 3, ... So this is then we have 1, 2, 3, 4, and a lot more. Wait, isn't there like any nice how to make nice visualization neural network? Nope. Okay, we should add a nice image here. So let's to do add nice image. Right, so the deep neural network is just a 3-layer. Oops, that's ugly. It's very simple actually. It's an input vector. It's a 784 input vector. Then we have a very big layer, which is so this is 784 by 1. Then we have 1024 hidden layer with leaky relu and dropout. And then we have another hidden layer, which is 512, which also has a leaky relu. And also dropout. And then finally we have the last layer, which is just a single thing, which is a sigmoid activation layer. No, wait. No, we have another one actually. 1, 2, 3. There's another hidden layer. So there's this 3 hidden layer model with 256 hidden. And this one has also leaky relu. And dropout. And then finally we have the, last but not least, we have the hidden, so the output, right? Which is a sigmoid activation layer. Okay, so that's the timer. Linear and then a sigmoid activation layer. This is the one sigmoid. All right, and then we have a lot of parameters going this way, right? I don't even know how you would visualize this. There are just too many parameters. So like there are honestly like so many parameters in this model that I sometimes wonder like how badly do you want to kind of, I don't want to say overfit, but at what point is, like, how many parameters is enough, right? If you have more parameters than data points, then, I mean, in econometrics at least, if you have more parameters than data points, your model is overspecified and you can always get a perfect fit. If the data is not collinear. But in this case, I don't know if this is even, if this looks nice, all these, I don't know, they don't look that nice. So let's keep it at this, I guess. Maybe like this or something. Here we have one, another one, another one, I guess. Whatever. So that's the idea, right? So the architecture is clear for everyone. What kind of model we're working with. We have a lot of parameters, so I might actually make the model a bit smaller because we might have too much parameters over here. So let's save this. Let's name it D. Oops. Let's just call it D. D. No. Okay, Namlos. All right, so oops, that's the wrong one. No, it's actually the correct one. All right, I will have to make this nice, right? But this is the main idea. So here we have 780 times 1,000, which is almost 800,000 parameters. Then we have 1,000 times 500, which is 500,000 parameters. So that brings us to 1.3 million parameters already. And then we have 1.3 million parameters plus, can I count? I probably am very bad at counting. I'm very bad at mental arithmetic. So if we are not using any dropout, we are getting 784 times 1,000, let's say 1,000, plus 500 times 1,000, plus 500 times 250, which is plus 256, which is roughly somewhere in the ballpark of 1.4 million parameters. So yeah. So we are optimizing over 1.4 million parameters in this model, which is admittedly, in my opinion, is a bit, I don't want to say excessive, but excessive. Okay, so we actually are finished with one session again. So the end time is 1946. And our goal was to read through the whole tutorial, which we did. And then start working on the tutorial, which we also did. So that's good. So We actually copy pasted the logger and the we did the logger. We kind of skipped the logger, loaded in the MNIST data, and worked on understanding the discriminator class, right? So that's kind of what we want to do. So right now we kind of copied this guy's code, but what I think might be cool is that if we can adjust his code such that we can make sliders. So we can say like, okay, I want this much hidden layers in my model up until maximum like 1 to 3, and I want this this much parameters, etc., and this activation layer, and then we could maybe visualize what changes, right? But in my opinion, there are way too many parameters in this model. But yeah, let's see. Yes. So this is the discriminator class, right? That separates fake from real data. So it takes as input, it takes an image and it outputs a number between 0 and 1. And next up, we're gonna work on the generator class. And then, if I'm correct, we have a to-do nice image, and then we can add a code snippet. But that is for the next session. So I'll see you guys in a bit, okay? Tea break. think it should be working now. Hey guys. Excuse me. Sorry. Yeah, I'm a Twitch affiliate now. I have no idea what I can do. Or what I can do actually. But oh wait, I can do affiliate links now, right? I can plug you guys some books that I think are really cool. Wait, how does this work? Twitch affiliate link or something? Revenue, cheering, game sales. Can I be a partner and an affiliate? One sub emote, game sales, ads. No stream delay option. That's cool. Reruns. Awesome. Sorry. Whew. All right, let's get back into whatever we were doing. I'm gonna set a timer. So we made the goal for this stream, read through the whole tutorial, and what we can do now, I guess, is that we can work on the I would first talk about the generator class actually. But okay, so let's talk about the generator class. Let's talk about the generator class. Write it out in the notebook. If we are done, we can continue with the tutorial. How will I get started? I mean, continue. Hazards, internet, phone, the usual. All right, so let's go to the not this one. Not this one. Did I delete the tutorial? No, here it is. So this is the tutorial we're using. So we went through the code for the discriminator network, and now we are going to need the generator network. And this thing is in between. All right, so let's put down, let's see if this runs. And the generator is actually the same, but the generator is just a neural network that takes in a vector of 100 random noise things, like 100 like a vector of size 100, and it outputs an 784 vector. And we use a linear with 256 leaky ReLU. Then we have a 256, and we upscale it to a 512, and then we have a 512, and we upscale that to a 1042 24. And we all have leaky ReLUs with the same 0.2, 0.2, 0.2 is in here, but in the discriminator we use dropout, and in the generator we don't use dropout. Why? I don't know. And then in the end we downscale that again. We downscale the we downscale the 1024 to 784, and we apply 10H layer in the end. Let me see what I forgot what the 10H layer looks like. Let's see. Okay, so that scales it between 0 and 1. No, this is a sigmoid. The 10H. All right. We could have just as easily used a sigmoid, I think. Okay, so if we make an image for that, it's basically the same image, but But in this case, we have input is going to be 100. Then we have it's all flipped around. Then we have 250, 256, 510, and then, so I'm just gonna change these by size. So we start small. We kind of start small, so to speak. I'll just redo it all over again. So we start with a vector of 100. Then we go to a 256. Then we have a 512. Then we have a 1024, and then we rescaled it back to like 784. So that's basically the architecture of the model. So we have 100 input. Then we upscaled it to 256 with leaky relu. Then we have a 512 hidden layer also with leaky relu. Then we have a 1024 hidden layer also with leaky relu. And these have no dropout. Then here we have a 784 as output, then edge layer. And a linear, yeah. So the linear refers to just the linear operation. So that refers to all the weights, right? All right, so here we have this. So that is the output, right? So we start from 100, we upscale, and then in the end we downscale a bit. And this is our output. Let's save that under nameless 2, I guess. And then we can insert that, but we still have to make it nicer, I guess. So let's upload the image. I want a direct link, actually. All right. This is slightly annoying, but we can deal with it. Whew. Okay. So that's that architecture. We got this under control. We got that under control. Let's see if this runs. It does run. Then this is like a kind of a trash function that we do need, but let's put that below this one. Excuse me. And then the generating noise, that is part of the generator, right? So we're gonna file that under the generator header, where we now generate noise. So the noise generator is what goes into so if we get rid of all of this, and we make it a bit smaller, let's make it a bit smaller. Then we'll say we have a red box, which is the noise generator. Right? And that just generates noise to use as input. and that results in output. So that is, can upload that as well. It's the other way around. All right. So any questions so far? I don't think so, right? This is fairly straightforward what I'm doing right now. So let's delete this. Let's delete this. So we have the discriminator, which is like this part. Maybe I should do it. Maybe I should do it differently. Maybe I should take this image, right? Should I take that? Maybe I can do it like this. Teen. Oh my God. You're kidding me, right? No, you're joking. You have to be joking. Oh, you're not joking. I should stop wanting to get back into stuff so quickly. Thank you so much. All right, so another idea of was to maybe do it like this. Like put it like this. So the discriminator. File, save as. GAN. And then maybe we can add it like here. That is another possibility, I guess. Imager. I don't know which one I like more. Like which one is nicer to see, this one or this one? So first we're gonna write down the discriminator, which has this architecture, and then we're gonna work on the generator, which is this thing. Task for another day could be adapting this code to work with multiple classes. What do you mean with multiple classes? I don't understand what you mean with multiple classes. Multiple classes, huh? Let's write this down. A generator that can generate multiple classes, but it is generating multiple classes. Like the generator, you give it noise and it should generate fake images, and it should, like, that is, it should be able to generate all of them, but of course, that might prove to be really difficult. I've read stuff. I've read like I've read blogs that had trouble with making the GAN generate different images. So what happened was that the GAN turned out to only train a single number. So I think we talked about this, like NumPy only GAN, and he ran into some troubles where he was only able to so we didn't want to do this, and that's why we are working with PyTorch now. So he has like 2 hidden layers, 300, 400, and 200 input size, and we now know all these things, right? And our model is significantly significantly bigger. So this is like the same amount of parameters. This is roughly 1.4 million parameters. And this is also 1.4 million parameters, which is admittedly, yeah, an insane amount, right? So we are optimizing over, well, not necessarily because of the dropouts. So in expectation, we have, I think, less parameters, but it's just an insane amount of parameters to optimize over. And then we have the noise generator, which is a nice schematic view, but of course we can also just put it in here. So the noise generator is just like we literally generate random noise from a Gaussian distribution, which we put in the generator, and the generator gives us back hopefully something that resembles something like the training set. That's the main idea behind the GAN, right? And we're trying to get that working in a Collab notebook tonight. Why? Because I don't know, I think it's cool. So let's copy that. We can make these images nicer and better if we can polish this. So I think I can get rid of this one, right? I like the. Okay. So we did this, and this, and that means we're almost done actually. Well, almost done. I mean, you're never almost done, but let's wait. The goal was to talk about the generator class, which we did already. So we already talked about the generator class. So the generator class is a. Wait a second. Leyendecker says, how do you select what class will be output by the generator? That's a very good question, and I think the answer is you don't know. And the second question, is there any other input than the noise? No, there's no other input than the noise. No, so that is also one of my problems with the GANs, right? I think that it's weird. Why would you put in noise? Sort of what I would expect is that, what I would expect is something like this. So, oh wait, let me save this as, I don't know, blah, 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 blah. So, what we have now is, so this is what we have now. Can I make it a bit thicker? This is what we have now, or at least what a GAN, what a GAN does. What I'd expect to like, kind of, what I'd expect is the following, where instead of random noise, right, you say, okay, like I want number 8, or number 0 to 9. 0 to 9. That is kind of what I'd expect, which then of course would be fed into the generator. But yeah, maybe there are GANs that do this, but I have not read that much about GANs because we have spent so much time figuring out like a normal GAN. I think there may be noise and other input. There may be noise and other input. What do you mean with noise and other input? Of course, what we might okay. So what I'm thinking about now is that what we could do is we could split the training set, right? We could split the training set into, for example, if you have only images that contain a 1, right? And then that would, if you have like, so we could, for example, idea, question mark, split the data set. Because imagine if you have only training set that contains images with a 1, then the generator will learn how to make a 1, etc., etc., etc. Leyendecker says, like, noise is one input, then there is another. No, noise is the only input, but actually noise is not even an input because noise comes from a distribution that you have to specify yourself. So it's not something you put in the model. it's like a source of variation. Like there's like a source of randomness that drips down into the generator, which I think admittedly is a bit weird. But let's write that down here as future ideas or notes, like future ideas. It could split up the data set into all sets where, for example, the label equals 1, and then the generator would learn how to make a proper 1, right? That's what I think. Because what I think that might happen now is that the generator gets stuck in, I don't want to say an unproductive local minimum, but I'm afraid that the generator might get stuck in generating only 8s, which fool the discriminator, but still it only makes 8s. This is what I think might happen, but I'm not sure because we haven't trained it yet, right? So actually, my idea is to throw down all these numbers like significantly and see whether it can be trained in like 5 minutes or 10 minutes, right? Because he says that its training takes 2 hours over here. So maybe we can put down the epochs into like 1 or 2 and then see how long that takes, and we can interpolate from that how long it would take in general. So now we have almost everything done. So now we are going to do the like, so we can abstract away from this, we can abstract away from this, we can abstract away from this, and now all we have to do is like set all the other parameters. So we have the like the other stuff, like other parameters such as the trainers and training. So other, so training. So now we can abstract away from this as well. So the logger loading in the data, we have the discriminator, we have the generator, and now we're putting like the dots, or we're crossing the T's and putting the dots on the I's. So I'm gonna take this to the other side. Yes. No, I'm not. Sorry. So we have the generator trainer, we have the discriminator trainer. So let's start with the optimizer. So the learning rate is a parameter that you have to choose yourself. So that's a hyperparameter, which can be fiddled with. Then the loss function is the binary cross entropy loss function, which we discussed a bit. So binary cross entropy. And now we kind of have to, I still want to check it again. So NNBC loss. I think there was a nicer. Okay, so the target vectors are 1's target size, a tensor containing 1 with shape is size. 0's target. Tensor containing 0. I don't know why I need this. I don't know why I need this, but let's, for the sake, for this time's sake, let's keep it at that, I guess. Then we are, okay, conditional GANs. All right, so that's called conditional GANs. Okay, I have to check. I'm opening it on my other screen. Conditional GANs, written by Mehdi Mirza and Simon Osindero. Let's see how many citations this has. 1,000. That's a lot. Let me see. We wish to condition both the generator and the discriminator. Awesome. Yeah, exactly, right? Exactly that. Yep. Conditional GAN. So that's basically conditional GANs. All right. Let's see. So we're gonna train. So Okay, so while we're training the discriminator, we're keeping the generator fixed and the other way around. So we have the... I have to see what we're doing here. So we are... So this is just a function we call... So how do we call this in the end? In the end, we call the function using... real data, generate fake data, then we train it with an optimizer, real data, and fake data, and then we train the generator, and then we log, and then we display it. Okay. So we train the discriminator by inputting fake data, real data, and the optimizer, where the optimizer is a function. We define the optimizer above here. Which is an optim atom parameters. Okay. G, okay. And then we reset the gradients. Sure. Why is n real data size here? Train on real data. So we call the function discriminator. And the discriminator, we call the function discriminator with the real data, which is just the... So why is this discriminator? Why is this not like feed forward? I would expect this to be like discriminator feed forward, but he just... I mean, obviously his code works, so... But why is this not feed forward? Or is it feed forward? Because we instantiate discriminator... We instantiate the model D in the end, up in here, which is just a discriminator net, right? And the discriminator net... like... So let's see what discriminator net, what that has. Is that a thing? I don't think that's a thing. That's our class. I think that should be just a forward. Okay, whatever. Prediction real CUDA. Then error real, loss, prediction real, ones, target. Okay, so it's a ones because it's a real data, right? So ones is real data. And now we have to actually... I think we have to cross-check the error because we use... Okay, so let's first paste the generator here because I think that the loss functions here, we have that the loss is BCE loss, right? And here we have loss, and here we have loss. But in all honesty, I think that the paper doesn't use BCE loss, right? I think the paper uses a different kind of loss. And the paper also uses, what's it called? Minibatching. And I don't see any, I don't see any minibatching here. But perhaps that is because we are iterating over the epochs because we have the batching which we did in the beginning. So in the beginning we loaded stuff. Let's see. in the beginning we loaded the data, and here we made batch size 100. So we're gonna iterate over the data loader here. So for end batch and real batch in enumerate. So we are gonna roll over that. Okay, so let's see whether we can run this actually. Now I'm kind of curious. This should work. Did I set a timer? Yes. All right. Then we have the generator. We reset the gradients. We make the predictions. So wait, this is a typo, right? Prediction is discriminator. Ooh. That looks like a big typo, is it not? Or am I mistaken here? Guys, could you help me out? That's a big typo. This should be generator, right? Or am I getting sleepy now? So we trained the generator. The prediction. Sample noise. I think I'm getting sleepy here. Wait a second. So we input fake data. Oh no, we make a prediction. I'm getting sleepy. So we have a prediction. One's targets. We want to fake it. So we want to make the prediction as big as possible. So that's correct. And then the optimizer, so and then we update. Okay, so the optimizer we put in there is the atom for the generator parameters. Okay, so it actually does work. It does work out, right? But generate fake data is already done. It's not sample noise and generate fake data. No, you make the prediction. Return error. Return error. Sure. All right. So this should run. Okay. And then num test samples, test noise. Is noise num? I don't understand. I don't want to say understand this, but what is this for? Wait a second. Test noise, test samples. And then we train this. Okay, so let's just copy this and put the epoch to 1 and see what happens. Let's put the epoch to 1. And then let's run everything, or let's run everything below this line. So run time and then run after. All right. So here goes nothing, I guess. So theoretically we could just get rid of this, get rid of this. This should work. This should also work. And here we get an error, of course. Wait a second. Num test samples. Maybe you need 2 or something. Logger. Log images. Test images CPU. Num test samples. If batch is 100 equals PIL image. If you do this to 200, let's see. It still gives an error. Okay, let's see if we can just put this to 1 and comment this out. So let's see what happens. Okay, so it's doing something. Not entirely sure what it's doing, but it's doing something. Oh! Alright, it's done. So okay, we can comment this out, and then so it gave an error when we tried to write something on logger, right? So logger is something, but logger log images didn't work. Let's Google this. Logger log images. Ignore me. Huh. Epic and non-epic. Maybe they are meant to be the same. Not as wrong. Ignore me. I won't ignore you. I will never ignore you. Let's see. Let's look at the error it throws. So it throws an error in logger log images, test images CPU, epic. Maybe maybe there's a space here that should not be here. If I remove this space, let's see what happens. No. Okay. So let's see if all the things are defined. Oh, wait, so this is the error. Let's Google the error. Be sure to comment out the following 2 lines. Do not run them. I also spent, there's actually no function name. All right, so different people. Maybe pip install upillow. All right, so let's try to install pillow. Let's see if this does something. Requirement already up to date. Okay, let's try it again. PIL image has no. All right. Pip install pillow, pip install, import PIL image. Import PIL image. Oh, maybe we didn't do that. Wait a second. I recall seeing something up on here. So did we actually run this? Import. Wait, maybe something's wrong with. Okay, so let's try again. Collaboratory fast AI. I'm getting attribute occurred in my collab as well. Do not run those. Okay, so comment out multiple line in line to be safe. So he wants me to. So we have double. This is not very Pythonic, so we can get rid of these, I guess. All right, so let's run all of them. Maybe let's run all of them. Okay, requirement satisfied. Torch vision satisfied. TensorBoard satisfied. We talked about GANs. Then we import. We create the logger. Then we do something here. We load in the data. We load in the discriminator class. Generator class. A random noise generator. And then we train it. Discriminator class. Generator class. And we still get an error. But wait, can I run this? So can I run this notebook? Logger. So let's logger test images CPU. Num test samples. So we can set the num test samples to 5 or something actually. Epoch and batch num batches. Epoch batch num. So that just plots the image, right? This just shows the image, like. Test images data. Vectors to images. Generator test noise. So why do I get this error? Let's Google this and maybe see if there's an up-to-date way that log images does something. Logger log images. Let's see what this does. TensorBoard logger. Let's search for log images. So that's a function. Log images for given name. I have no idea. Like, I don't understand this error. Okay, so maybe we can just get rid of. Okay, so maybe just let's not try and see whether it works. Okay, so it's trading for 1 epoch now. Okay, so we can give a nice clap for ourselves for being able to copy code of someone else. But in all honesty, we did check most of the code except the logging part, because I have a little experience with logger so far, which is the Python standard, so I should definitely learn it. We did not change anything with respect to all the layers, so we have like tons of layers, tons of parameters actually, like more than 2 million parameters, which is just absolutely insane. It's just weird that the logger is a bit that it doesn't. I wonder now if it maybe if I now go to my drive, I kind of wonder what happens, right? I wonder if I can see the drive. Let's go to my drive. And because it saves, I think it saves the logs, right? Collab notebooks. GAN. It doesn't save the logs anywhere. It should, right? Log images, log, right? Log images. Oh wait, so log or log images? Okay, so save images. Okay. Okay, so uh dx is the probability of okay. We are It's almost done training, or is it done training actually? It might just be done training because it starts at epoch 0, I guess. So I think it's done training. Okay, that's awesome. So now we can look at, we should be able to like view some of the images, I guess. That's a timer, but I really want to see the images. So let's just look at this. Let's see what, can we copy this and then paste it in here? Let's paste it in here. So if images NP array, otherwise transpose it, sure. We don't care, we don't want it in a function. What we do want is to unindent this. And then we are not caring about the logger, not caring about this. Make vertical grid. Alright, so this errors, right? Name images not defined. Okay, let's just get rid of the sure. Because images is so images is, I think, test images is test images CPU. Alright, so normalize is not defined. Oh, this is utterly annoying. First if has a space around it. In this one, let's see. Yeah, but that's not the error. That is not the error. No, I fixed it already. But I don't understand why this thing doesn't work. Like, it throws an error. But okay, so let's be good. Let's be good Python people and see what the error is. So okay, let's start from the beginning. What function call generates the error? So logger, log images, test images, CPU, num test images, and then on line 39 suddenly it says in log images add hard. So it can't write the images, and it can't write the images because tensor rescale image save output is PNG. So pre-init. Okay, what if I type this and then with Collab, type Collab after it. Pip install pillow. Okay, I'm gonna copy this and hope it works, which is actually a really bad way of doing stuff. But okay, so it didn't throw an error. I'm gonna add the Stack Overflow link there, and then see if it still throws an error. It still throws an error. Now it throws a different error. Now it says has no image register decoder. Okay, so let's restart the notebook, I guess. Hey, Ridari, hey man, how you doing? Hope you're doing well. We are just fixing the last of our bugs in the code. Because we can't seem to get this thing to like plot the images. It turns out everything works except that we want to show the images. We want to log the images. But it turns out that that is strikingly difficult. So okay, image register decoder. Let's see what this is. Maybe we need to update Pillow or something. Just reinstall the PIL. Let's reinstall the PIL. All right. And let's see if this works now. I highly doubt it. Has no attribute. Okay, let's can we can we restart it in some way? Insert runtime. Reset all runtimes. Sure. That's fine. All right, so let's run all. What language is this? Python 3.6, I believe. Yeah. But we're working on a notebook. We're working on a Python notebook inside Google servers, which is really cool. They're offering like, oh, enter your authorization code. Yeah, Python. Really cool, right? Okay, so now we're downloading Torch again, which is something we're gonna have to do every time. Wait, I have to, we're almost done with this, right? So that is 10:48. 8:48, 20:48, I mean. Yeah, and we did that. So we almost finished the tutorial. We copied a lot of code, but we are understanding the syntax of PyTorch, which in my opinion is quite readable. Yeah, maybe it was a bit of hubris and like overconfidence of thinking we could program in our own whole machine learning framework. It might be interesting as a side project later. All right, so this works. It loads in the dataset. The generator works. Then we initialize this. Okay, we still get the error, right? So we still get the error. So let's see. Okay, so log images doesn't work. And then the self-writer image doesn't work. Save image, save output. Search Stack Overflow. I love how there's just a like a button that says Search Stack Overflow. How to ask for help. Okay, let's look what this guy says. Like I want to know both the fix, but I also want to know why. I want to know why it doesn't work. And Yeah, so I had this. And that turns out to be a whole different error. Okay, so let's try this and then try fixing the other error. Okay, so we try this, which is suggested in this post, and then we try something else. Let's see. Okay, so I know this runs, but then we have this error. When I use the code on Google Colab, above error is arise. Yes, I am facing same problem. Install Pillow and restart, that solved it for my stuff. 26 days ago. That's actually pretty recent. So, as no register decoder is actually... Okay, so let's see what kind of pillow we have. I know, I'm so sorry, guys. This is not the most interesting stuff to watch. Oh, look at this. This is bad. So, this should be 5.3.0. So, just as I say it, we actually might have found the bug. So, let's install this and then restart and then look for it again. All right, so we have to restart the collab. But we installed this, right? Like, we installed it here. All right, so what if we type it like this and then we put this on the top? Because I think we uninstalled it and tried to install a different version. Okay, so let's add that over there. And let's, if I exit this, maybe everything breaks down, but I'm not sure. So we can go to copy of GAN, and then we go open it with Collaboratory. Now we run everything. Now I have to authorize again, probably. Which is fine. Oh, drive already mounted. Oh, 4 point, look. So why is, so, okay, so this is weird, right? So we install PIL, and then we print PIL pillow version, and we get 4.0. So that is, I think, the bug. But then why does it say requirement satisfied pillow is larger than... this is very confusing to me. So why is this 4 point... So this should print like uninstall, install, and then import PIL. And if it doesn't, restart the runtime. Alright, so I guess we want to try it again. I think it's quite weird. Four! Huh! Okay, so let's go runtime, restart all runtimes. Or reset all runtimes. Restart runtime. Okay, runtime, and then... So let's see what this does. Import PIL. Okay, so... can I now train this? Logger is not defined. Okay, so now we have to run all. And pray to God that it works. Okay, that's good. That's really good. So it might work now. You're never sure, of course, but it's a good sign. Um, I want to thank my overnight subs, by the way, for joining. I got like quite some subs overnight, so thank you so much for doing that. Let's see what errors we get. Oh wait, we don't get any errors. Oh shit, guys, this is awesome. Look at this. This is what we're doing right now. So we are training our model. So our model is working, and this is a GAN. So this is a GAN. We are training a GAN right now. Look at this bad boy. Look at this. All right, so we can. So that's one epoch, right? Yay! Yay to us. All right, that's awesome. So wait, let's before we get our hopes up, let's write down how we fix the error, because we had a bug where we had a PIL version equals 4.0.0, and we fixed it with forcing the installation of 5.3.0 and then restarting the runtime. Awesome. So yeah, that's actually really cool. So what do we see here? We see test images CPU. We have num test sample, so that is 1, 2, 3, 4, 5, 6, 7, 8. So we can make that 8, 5 or 16. That doesn't matter. And so we show test images, and so we make test noise. So these are 16 of our noise that we then put through the generator, right? And this is after the first epoch. This is after the second batch, third batch, fourth batch, sixth batch. As you can see, it doesn't look like anything, but we are just gonna let it train for let's say 200 iterations. I don't know. That probably is gonna take way too long, but I'm just curious to see like what comes out of it, right? So this is, I have to admit, it's kind of cool. So we are actually training again now. So that is exciting stuff. Maybe we can even save the images. Save the images. Let's see if we have a function for that. Log images, and then we have save torch images, and we have let's see. Fig, save fig, epoch batch. Comment. All right, I want to see if we can save the images somehow. So logger dot save images, and then we have like, yeah, what's the figure? So fig gets called fig save fig. Okay, let's see what kind of error this throws in. So fig is not defined, right? Fig is not defined right now. Epoch is defined. Fig is the image. All right, let's run it. Cell is already running. Fig invalid content, of course. So let's say simple GAN. Let's run this. Oh, what? What is this? This looks way too much like numbers. Is this generated? What? That looks way too much like actual numbers. Figure's not defined. Yeah, so figure's not defined. Because so maybe I can just add like in the log images, maybe I can just add a call that it saves the file, right? So instead of so it adds it. Oh, it saves. Oh, it actually calls it. It calls save torch images. Oh, okay, that's cool. So then we have to look in the output directory. It actually saves them already. But now, like I don't see a data directory here. So GAN, and then that's it. So let's see what print out there does. Let's see. We are here. So out directory does not get printed. Okay, so out directory does not get printed. Well, I'm pretty sure it should get printed. So we're calling log images. Logger logger.log images save self.save torch images. And torch images outputs that to out.data images. Data subdirectory. Model name. Data name. I don't believe this. Let's see. So, so the dot directory means like going up, right? It's called the current directory. So maybe we need to make a file that is called data and then images, or like I think it's weird that like the directs like so wait should be like this, Python 3 of course. Maybe that's why it didn't get printed. So let's try that again. No, it's still like, and for some reason this is looking way too much like actual numbers, which is surprising me a lot because let's stop this and let's go to like log batch error, sure, but the point is I want to save the freaking images. So I think it's weird that, okay, so if we're logging the images, but print out there is not being called. So this function, So we are logging the images with log images here. But then we do this. We have, okay, so let's print out image name. Let's print image name. Then we make a horizontal grid, make a vertical grid, and then we add the images, and then we save it. But save plot doesn't get called, because otherwise we would print this, right? So let's say print line before save torch images. Oh, of course, we have to run everything all over again if we want it. If we want, of course, that's a cellular structure of an IPython notebook. You cannot run things out of order, save them. Maybe run the code where logger is defined. Yeah, my bad. I forgot that. I definitely forgot that. So now we are running everything again. All right, so yeah. So now, yeah, it gets called. So, so images, so data images vgan. But it's like vgan mnist. But then why is it not creating those? Why is it not creating those data? Or maybe it is actually. Maybe it is. Because if I type now like ls, okay, so I learned that like it does save it, but so it does get saved, but in some place that we do not understand, that I don't understand. So the images do get saved, but somewhere I can't find them. So as we see, and if we type ls, right, Hori epoch, they get saved somewhere, but where? Like how to open Collab map on Google Drive. I just read that you have to mount your collab sheet to your drive, but we did that in the beginning, right? Here, drive already mounted at content drive. Drive already mounted. What is how to read data? It's like how to access. Oh yeah, I think yeah. Yeah, so yeah, wait a second. So of course. So it is drive, right? It should be in drive. So let's see. So if we now type ls drive, we should get my own drive now. Drive, my drive. Does this work? It has a space in there. That's risky. Yeah. Let's see. So drive and then oh. Maybe we can do this. Would this work? But then ls is my drive. This doesn't work anymore then. It does. Alright, so this is our drive. But what is now our working directory? So os get working directory. What is oscw get cwd? Okay, and then we go to, what's this folder called? Collab Notebooks, I think. I think there is a autocomplete somewhere available. Yeah. Hey, Vinolanda, thank you so much. I've seen you before, man. Thanks for, oh, drive, no such directory. Yeah, so this is what we want, right? This is exactly what we want. So, let's change directory. And, definitely we are going to have to write this down. Yeah, so we are gonna have to write this down. So, let's write this down. Images get saved. So the fix for this, recall that you mount the drive and have to change directories. Alright, so technically, I think that we should be set now. I think that we should be all set now. We don't need this. Alright, so, yeah, so let's run all and see what happens. Drive's already mounted. We changed directory. We installed Torch Vision. We did that already, so it's gonna run over that. And then our Google Drive should slowly start filling up. Maybe not. Let's see what happens. Let's see what error we run into. So here we have GANs. Here we have more GANs. We have nice images. GANs. Okay, so it's saving it. It says it's saving it. Okay, so this looks worse than expected. This looks very bad, but hey. And it saves it in data images vgan mist. Ooh, look at this. It's slowly filling up. So data images vgan mnist. There we are. That's pretty awesome, right? Okay, it looks like absolute it doesn't look like anything, but it's cool. What is the hoary thing? Like, where did we do hoary? Hoary. What does that even mean? And why does it save it in a 3x3 grid? So that must be in here somewhere. Load images. Plot and save squared. Self-save images fig. What's the name then? The name is out directory. Comment is empty. Oh, horizontal stands for hoary. Yeah. Sorry, I kind of defaulted to hoary. They make sticks, so I sometimes play fighting games. Not often, but I used to make them. I used to play them. I actually made my own fighting stick, which is kind of cool as a software project or hardware project. I don't want them. I don't want them horizontal. Oh wait, actually, I do want them horizontal. Okay, this is really cool. But at the same time, I hate Google Drive, so I wanna bulk download all of these. Look at this. It's pretty neat, right? Yeah, look at this. It gets stuck in a local minimum. You see, they are not changing at all. They're not changing at all. Oh wait, here they are. Whoa. What is this? This is pretty awesome. So that is epoch number wow, it already. We should write this to like a log file, like a PDF or something. Epoch 6 already. That's pretty fast. Epoch 1. Epoch 5. Alright. So as you can see, it looks like it's already... It looks like it's stuck in an unproductive local minimum. The generator log... Okay, so let's look at this. Whoa, okay. No, wait. So the discriminator loss... Okay, so this is a thing that is known about... this is a thing that's known about GAN. So the generator is so bad... the generator is so bad that the discriminator is perfectly able to separate the fake ones from the real ones, right? So this way, the generator has no way to get better because he keeps getting caught and he can't, like, he has a lot of trouble figuring out. So yeah, so you guys understand what I mean, right? This is a problem which is noted in the paper, which is let's go to generative. I think this is called supersaturation or whatever. Not supersaturation. I think it's called, like, if you Google saturation, you get it here. In practice, so this is exactly what is being talked about in the paper here. So it says that in practice, equation 1 may not provide sufficient gradient. Early on, when G is poor, D can reject samples with high confidence because they are clearly different from the training data. So log 1 minus D saturates, and rather than training G to minimize this one, we can train G to maximize this one. So we might have to change that because right now we are stuck in an incredibly unproductive local minimum. But I think it's really nice that we illustrated that. I think it's nice that we illustrated the fact that a GAN can get stuck in exactly what he talked about, right? That's pretty awesome. That's really cool. All right. I'm really happy you guys were with me, all my three viewers, for this ride, which was pretty awesome, I think. So I'm gonna write that down. Actually, I'm gonna write that down. So, we finished. So, what did we get done? Actually, we were able to finish the GAN tutorial and have a working example of a trainable GAN in the Collab Notebook. Awesome. We also illustrated the unproductive local minimum where the generator is so bad that the discriminator is able to pick out the bad ones with 100% accuracy. Oh, decent, I guess. Madam, I just realized your green screen is dead. No, my green screen is not dead, actually. That's I think it's funny that you only just realized, but my green screen is not dead. It's just that I haven't gotten it to work on this computer, Because so the story is like this. People wanted me to stream on this computer, so I said fine, I'll stream on this computer, but I don't have a webcam, so that's one of the reasons I streamed on my Mac, because it has a somewhat higher quality webcam, right? Um, but on my Mac I have OBS set up such that it filters out the green screen. But on this computer, I haven't took the liberty. Like, I don't have a webcam that kind of is nice quality. So what I'm doing right now, I have Skype on my MacBook open, and I'm Skyping myself. So this is just a Skype call. So my webcam is just a Skype call of myself, which I think personally is hilarious. But so yeah, you can see my green screen. I hope you guys don't mind, but I just really wanted to get a stream in this evening because I was just so excited about GANs, and I really wanted to get a working prototype, and I'm really happy we actually managed to get a working prototype. So yeah, I'm really glad about that. I'm honestly really glad about that. I do think it's weird that he gets different. Look at his starting. It's way yeah, it's different. His starting values look different, right? So our starting values look something like this. Oh, oops. Like way more black and white. Like there's black and there's white. So another thing that we can think of is that it saturates into the extremes, right? We see black, we see white. There's no gray in the middle. So from this we can infer that like a lot of the things are saturated. So the generator right now, we need to introduce some randomness in there. Yeah, so the loss is getting bigger, right? So we could basically stop the algorithm. So I think it might be more productive to like stop the algorithm, because it won't get any better. It will only get worse. But that's pretty cool, right? So we have a lot of images now. A lot of images. So it got stuck in this unproductive minimum. The first sample was weird with all those numbers. Yeah, so let's run it again, because I'm a bit curious now, right? So let's just look at the first sample. I'll look at the evolution. Wow, what's this? That's crazy. See, it has like, this kind of looks like a man that's running or something. And this is... So, look at this. So, it starts off pretty well, and then it degenerates instantly, pretty much. So let's try that again. Ooh, so the first image already is pretty bad. Let's try that again. I don't know what's the problem with this. Why is it generating such extreme numbers? Yeah, no, I think it degenerates really fast into I think it degenerates really fast. Because we have like epoch, this is like epoch 0, batch number not. So noise n. Okay, so maybe if we change the noise a bit. So what if we change the noise? So noise. Then we go up to the noise function. Noise over here. So rand n is probably just a random torch rand n. So rand n is that random normal? I mean, that must be my guess, right? So what if we make like not rand n, but what if we make it into just a rand? Let's see what happens then. Yeah. What? It results in the same thing? That's really odd that it... So, but of course, this is one of the problems with the GAN, right? So this is one of the very... So this requires some hand fiddling, some hand tuning on the GAN. But yeah, I think it's pretty awesome that we got a GAN working. I honestly think that's really awesome. So I'm gonna debrief myself, and maybe I'm gonna let this train overnight, but I'm not sure if that even makes any sense, right? Because I'm pretty sure it will degenerate anyway into a pretty bad equilibrium. So I wanna let it generate over time, but it'll just stay in this equilibrium. So let's debrief. It was nice actually. So we did only half a stream, or half a stream only did like 3 hours, but I think we got quite some work done. I mean, we only streamed for 3 hours, but I still think that it was really nice that we were able to get a working prototype of a GAN up and running. That's very motivating. So we have to realize that we didn't write that much code. We mainly copy pasted someone else's code. So we definitely have to go over that ourselves again. Because copying someone else's code is definitely not the same as writing your own code. Then we did get I just think that it's really nice that we are training again right now. So the fact that it's converging to a useless equilibrium that doesn't say that much. Well, of course, it's important that we eventually get something that is able to generate the numbers, but I think it's fun that we got like a working prototype, something we can get our hands on. So what did I get bogged down on? I don't know, like not that much, I guess. Yeah, maybe I'm a bit tired. I'm always sharper in the mornings, but I had to do stuff in this morning. So what went well? So viewership is relatively low this evening. Maybe that's my fault for streaming on Sunday night European time. I don't know. Not that it matters, because what matters is that you guys are here with me and that we got a GAN working. So all the people who weren't watching didn't see the GAN in action. So that's on them. That's not on us. Yeah, so this is not really productive, but I'm gonna let it slide, I think. I'm just gonna let it train overnight and see what happens. But I think we should be really thankful for Google that they're providing us with these awesome GPUs. What went well? I got some great help from the chat. The chat and debugging. And I think I explained GANs to Leyendecker again. Any other notes? Do not forget to write our own code and not just look at others. Wow, stream 10, short but powerful. Yeah, I'm still glad that we did this, because I think it's yeah, because if we can generate images, we are done, I guess, right? So that's where we started. We started from wanting to generate images, and we ended up being able to generate images, right? So the fact that it doesn't work, I mean, of course, that's fine. But we can now start fiddling with this. We can start fiddling with the code. We can start fiddling with the layers, with the parameters, and maybe even add some convolutional layers or whatever, right? That's That's what I think. So let's see my Google Drive and see how much space I'm already using. I'm using a lot of space here. Can I bulk download this, you think? Yeah, download. Awesome. Oh no, I want to download everything. Give me everything. Vegan. Vegan almost spells vegan, by the way. So yeah, so that gets pulled in quite a bad equilibrium, right? Okay, so this basically concludes the stream, but there's a big but. I do want to say one more thing, I think. Yeah, it's not evolving at all. It's stuck. The loss is going up and down, and it's not really yeah, so this is the unproductive minimum we talked about. So I've been thinking about like the kind of like the fundamental properties of a neural network, right? So a GAN is made of a neural network, but I have some, I don't know, I don't want to say I have troubles, but I just want to get some thoughts down on the paper, because like we came to the realization that a neural network is nothing more than like a linear separator, right? So if we have the most trivial neural network we can think of, it has no hidden layers. It has input and it has output. And I think that the most trivial data we can think of is just the real number line, just minus infinity to infinity, right? And then at some point, at some big point, let's say on point A, which is filled, which should be filled actually. Everything below this line is 0. And everything above this line is 1. So this is 0. 0 if x is smaller or equal than a, like where a is some constant, and it is 1 if x is larger than a, right? So this is the most fundamental data I can think of. Like I first thought maybe you could put like ones and zeros, but I think the most fundamental data, like let's say the simplest case we can possibly think of, right? So this is just some ramblings on like kind of the fundamental nature of neural networks. So the input in this case, you would have x's. That's your input, right? So you would only have x's as input. So input would be x, which is just a it's just a one-dimensional number. One-dimensional number, yeah. And the output would be either 1 or 0. So then we would have one connection between these two. And this connection would be weight W, of course. Then, of course, we cannot forget the bias. So what this would give is it would try to find a function fx, because like x is the argument, right? It would try to find wx plus beta. And then the activation function. So let's call that f or activation 10h sigmoid. I don't know, like let's say 10h. So that is basically what the most fundamental neural network kind of does. But now we're kind of at the yeah, so and then it tries to learn these parameters. But so I was thinking like how many, so if you now not have this, but what if you have another part where this is 0, right? Like how many hidden layers would you then need? So I was thinking about that, but This is just some kind of rambling, kind of a bit of a rant on like what is a neural network and how does it work and can we visualize it and does it even make sense to train them? Like, are we not just taking parameters and kind of overfitting the model with millions of parameters, right? So the model we're training right now, like the GAN over here, has more than 2 million parameters. 2 million. Like, that's a retard. That's an insane amount. Like 2 million, and it doesn't even work. We have 2 million parameters and it doesn't work. Like, what is wrong with you, machine? Like this is not the way to go. I think that's not the way to go, at least. So you have 2 million parameters and you still get stuck in an unpredictable local minimum. Like there should be, yeah, it should be easier. So this is rand 1. Then in rand 2, I had an idea on, like, I was wondering how would a robot store a concept, right? So how would a robot store the concept of, let's say, backwards induction, or, well, I don't know, love, or betrayal? Like, how would you translate that to zeros and ones? How would you translate the concept of love or betrayal to zeros and ones? I think that's interesting to like think about. And then finally, I read this article, I think on Hacker News, about this guy who had like photographic memory. Let's see. How I changed the law with a GitHub pull request? No. Here, this one. From the New Yorker. It's about a man with an impossible memory, so he like remembers everything, but then at some point it comes to pretty, I think, funny thought, which says, here, deriving meaning from the world requires us to relinquish some of its texture. In S's case, as many readers have noticed, resembles the George Louis Bourget story Fin de Mémoire. I don't know if that's German or French. Anyway, a fictional work about a man plagued by the persistence of his memory. To think is to forget a difference, to generalize, to abstract, Borges writes. In the overly replete world of fumes, there were nothing but details, almost contiguous details. Similarly, Luria writes that for S, almost every word, every thought was freighted with excessive detail. Like, the point is that to think, I think that I kind of like this quote and I want to save it. Deriving meaning from the world, like thinking, to think is to forget a difference, to generalize, to abstract. I think that's a pretty cool insight, or I don't know if you can call that an insight, but I think you can call it a cool quote, and I wanna save it, because it might provide us. Because it might provide us. It might provide us new. I don't want to say insights because that's a big word, but kind of food for thought on what learning is. Like, what is learning? Like, is learning just optimizing parameters? I don't think so. I think that learning goes way deeper than that. I think more importantly that we need, like, at some level, learning is feature extraction, right? Because you have algorithms, and I mean, we see the data. I mean, our eyes don't like, our brains don't store all the information in the world that we see. We forget the majority, but we do extract some important things from that, like how not to die, for example. What food is hot, what food is cold, where to put your hands under to check whether the running water is warm before you step into the shower, for example. All those kind of things, right? You'll learn those, but how do you learn those? And another interesting quote is, I think, in nature there's no punishment or reward, only consequences. Yeah. This woman turns out to also have photographic memory, which is pretty cool. That's pretty awesome. All right, so let's see how our GAN is doing. This is not our GAN. This is like this guy's GAN looks so much better. Like, why does my GAN get stuck in the unproductive minimum? Did we do this? Did we normalize it? I think we did. Did it change the? Did it? I didn't change anything. So I think it's really weird that. Did we change the learning rate? No, we didn't change the learning rate. 16, 200 epochs. Like why does our GAN get pulled into the unproductive minimum? I don't get it. This is very confusing. Okay, I'm gonna quit it and I'm gonna restart everything. Okay, let's see. Let's drive. Copy of GAN, I think. All right, so let's run everything. I probably have to authenticate again. Maybe not. All right, let's see what our GAN is doing. Oh, excuse me, sorry. Oh no, it gets pulled into the. It gets pulled like. Is there any way to reset the random number generator? Okay, but that is maybe something something for later streams. Okay, guys, I want to thank you all so much for joining me today. Stream was relatively quiet today. I hope you guys were at least listening. Yeah, I had a lot of fun working on the GANs. It's kind of we achieved our goal, right? Our goal was to get a working prototype of the GAN, and we did that, so we can definitely be proud of that. Then we also solved quite some bugs, quite some things, right? So we had the PIL version bug, which turned out to be another bug, where we had to force an install and then reset the runtime. We figured out all the layers, a bit of the syntax, and we figured out where we had to save the images. So all in all, I think it was quite a successful stream for only 3 hours because we learned a lot. And I think the most important part is that we got a working prototype of the GAN. I mean, it doesn't work, but it's not. It doesn't make pretty pictures, but it does make some pictures, which was completely what we expected, right? We totally expected it to be really bad, but we can fix that in later streams. So yeah, thank you so much for joining me. I really enjoyed it. I hope you guys didn't mind the green screen I have up, because some people wanted me to stream from my big computer, from my gaming PC. So that's what I'm doing right now. So yeah, I want to thank you all so much for joining me on this lovely Sunday evening. And I'm gonna wish you guys a good night, and hopefully you guys had a great time hanging out with me. I sure as hell had a great time hanging out with you guys. So thank you so much for watching or listening, just tuning in, saying hi in the chat. I really like seeing regulars, so thank you so much for joining in. I really appreciate it. Yeah. So thank you so much, Lion Decker, especially Lion Decker, Vinolande. Greenie was there as well for a while. I think we had who was there? I think Ridari was there. Yeah, so thank you so much, guys, for joining. Just me, bro, of course. Yeah. All right. I'm just really happy that we got the GAN to work. I mean, it's cool to have like a working prototype, right? I mean, I think that's really motivating. To like have something in your hands that works. So it's not ours yet because we copied most of the code, but now that we know how to kind of now that we know the basic structure of the model, we can start working on more intermediate stuff, right? And I think that's really cool. All right, so next time we might just try tuning this GAN, which will, I think, be a part of machine learning that I will less like, but it's still machine learning. Okay, so once more, thank you all so much for tuning in. I had a great time. I hope you guys had a great time, and I want to wish you guys a lovely evening. Thank you guys so much.